Okay, class, today we're going to focus on Chapter 6, Section 6, reasoning about special quadrilaterals. It could be a bit of a tricky section, if you will, but if you pay attention, I don't think it'll be too bad at all. Okay, if we take a look at the objectives, Objective 1 is actually recalling the relationship among the different types of quadrilaterals. That's just review. The second objective is also review, recall the properties of each type of quadrilateral. Third, we're going to determine what type of special quadrilateral each shape is. And then fourth objective, decide if enough information is given to conclude that the given quadrilateral is the one stated. If we take a look and flip over at the first objective, this is the polygon flow chart, which we covered in 6.5 again, and you've probably seen it in a section before that. We're not going to go through the flow chart. But basically, just remember, as you move down the flow chart, we're getting more specific, and you branch off to the left and the right based upon the different types of quadrilaterals. Let's take a look at recalling the properties of each quadrilateral. I do want to spend some time recollecting these things. Okay, so let's put an X inside the box if the quadrilateral has the given property. Okay, so as we go down, okay, let's do parallelogram first. Let's read through the properties and put an X in the box if it holds true for parallelogram. Okay, so in a parallelogram, are both pairs of opposite sides congruent? Yes. Are the diagonals perpendicular? No. Is there exactly one pair of opposite sides congruent? No. Opposite angles are congruent? Yes. Okay, are the diagonals are congruent? No. Both pairs of opposite sides are parallel? Yes. Okay, I'll move down the screen here so we can finish the parallelogram. Okay, next one, four right angles, not in a parallelogram. Okay, are consecutive angles supplementary? Yes. Do the diagonals bisect each other? Yes. Is there exactly one pair of opposite sides? I can't read that, I'll move it down. Parallel? No. Are all sides congruent? No, not in a parallelogram. If we understand from the flow chart or recall that a rectangle, a rhombus, and a square are definitely all parallelograms by definition, then they all have to have those boxes checked for them because they are parallelograms. So that has to hold true for a rectangle and a rhombus and a square there, as well as here, as well as here. Moving down, as well as here. Again, why is this hold true? Because a rectangle, rhombus, and squares are definitely parallelograms. So whatever we marked for parallelogram, assuming you had it correct, we also have to mark for rectangle, rhombus, and square. And then we can just go back and fill in the blanks of each that may be added on to it. So now let's just focus on rectangle again. So in a rectangle, let's look at the blanks we haven't marked for rectangle. So are the diagonals perpendicular in a rectangle? No. Next, is there exactly one pair of opposite sides congruent in a rectangle? No. Next blank, are the diagonals congruent in a rectangle? Yes. So I'll mark that. Are there four right angles in a rectangle? Yes. Moving down to see the rest of the table for rectangle of the unmarked. Is there exactly one pair of opposite sides parallel in a rectangle? No. Are all sides congruent? No. So we finish with rectangle. Moving on to square of the boxes we haven't checked yet. Excuse me, rhombus. We'll move on to rhombus. So let's look at rhombus. Are the diagonals perpendicular? Yes. Is there exactly one pair of the opposite sides congruent? No. Are the diagonals congruent in a rhombus? No. Are there four right angles in a rhombus? No. Are consecutive angles supplement? Oh, we already have that one marked. The next unmarked underneath rhombus, is there exactly one pair of opposite sides parallel? No. Are all sides congruent in the rhombus? Yes. So for rhombus, we need to mark that one. Boom. Moving on to square now of the unchecked boxes. Let's read them and check them for square. First one, for square. Are the diagonals perpendicular? Yes. Is there exactly one pair of opposite sides congruent? No. Are the diagonals congruent? Yes. Are there four right angles in a square? Yes. Moving down, is there exactly one pair of opposite sides parallel? No. Are all sides congruent in a square? Yes. So that has to be checked. Done with square. Moving on to trapezoid. In a trapezoid, first, are both pairs of opposite sides congruent in a trapezoid? Absolutely not. Let me change my color here. Tried to change my color. It didn't work for me there. Let's try that now. Okay, good. Starting over trapezoid. Are both pairs of opposite sides congruent? No. Are the diagonals perpendicular? No. Is there exactly one pair of opposite sides congruent in a trapezoid? No. Are opposite angles congruent? No. Um, are the diagonals are congruent? No. Both pairs of opposite sides are parallel? No. Are there four right angles in a trapezoid? No. Are consecutive angles supplementary in a trapezoid? No. Do the diagonals bisect each other in a trapezoid? No. Is there exactly one pair of opposite sides parallel in a trapezoid? Yes. So that holds true in trapezoid. And are all sides congruent in a trapezoid? No. Last but not least, isosceles trapezoid. Let's go through this. Are both pairs of opposite sides congruent? No. Are the diagonals perpendicular? No. Is there exactly one pair of opposite sides congruent in an isosceles trapezoid? Yes. Are both, are opposite angles congruent? No. Are the diagonals congruent in an isosceles trapezoid? Yes. Are both pairs of opposite sides parallel? No. Are there four right angles in an isosceles trapezoid? No. Are consecutive angles supplementary in isosceles trapezoid? No. Do the diagonals bisect each other? No. Is there exactly one pair of opposite sides parallel? Yes. Are all sides congruent? No. Okay, let's flip over. Okay, here we go. Objective 3, determine what type of special quadrilateral each shape is. Example 1 reads this. Determine whether the quadrilateral is a trapezoid, a parallelogram, a rectangle, rhombus, or a square. Now, these can be very tricky because you may want to think that it's one, but I guess the trick here is this. You got to look at what's being given to us, what's marked, and then you have to be as general as possible. So we have to recall all the definition and properties for the trapezoid, parallelogram, rectangle, rhombus, and square, and be as general as possible. You can't be specific unless we're given that information to allow us to say that it is that special kind of quadrilateral. So for example, if we look at letter A, notice they have just told us that the diagonals bisect each other. Well, here's the question. Does that hold true in a parallelogram? Yes. Does that hold true in a rectangle? Yes. Does that hold true in a rhombus? Yes. And does that hold true in a square? Yes. The reason why we're not going to go with square or rectangle in this case is because we don't know anything about the angles in terms of the angles being four right angles for square and rectangle, and for rhombus being that the opposite angles would have to be congruent, which would also be true in some of the other ones. So being as general as possible, because we only know that the diagonals cut each other in half, we have to go with the most general one here, which would be parallelogram. If, for example, you said something like, oh, it's a rectangle, I would then ask you the question, you're now telling me that angle A, B, C, and D are each 90 degrees, and definitely that's not true. So you got more specific than the information gave us. Okay, let's look at letter B. Okay, what did they give us? They gave us that all four sides are congruent to each other. Well, which quadrilaterals does that hold true? That holds true for a square and for a rhombus. So in a square and a rhombus, that holds true that all four sides are congruent. So now let's compare square and rhombus. Do we know if those four angles are right angles? They didn't give us any information on the angles. So we can't be as specific as possible and go with square because we don't have enough information to use the cooler name. So we have to suffice and say that it is a rhombus here of the two. It is the more general of the two between rhombus and square. Let's look at letter C. Okay, so they told us that each interior angle is a right angle. So each of the four interior angles are right angles. So now we ask ourselves, in which of these choices are all four interior angles right angles? Well, definitely not in a trapezoid. That is definitely not true in a parallelogram. That is definitely not true in a rhombus. That leaves us with two choices. Well, a rectangle has four right angles on the inside, and a square has four interior angles that are each 90 degrees. Well, which one of these names is the more general? Rectangle. We got to go with rectangle because they didn't give us enough information to conclude the cooler of the two friends, if you will. So we have to go with rectangle there based upon the information. If we flip over here, okay, objective 4, we're deciding if enough information is given to conclude that the given quadrilateral is the one stated. Example 1, decide if you were given enough information to conclude that the figure is the given type of special quadrilateral. Explain your reasoning. Well, they're saying, is quadrilateral PQRS, can we classify this as a square? Well, you might be inclined here to say, well, yeah, it's a square because each of the four interior angles are right angles. But if you write down square, I'm then going to start asking you questions like, how did you know that all four sides are congruent? How did you know that the diagonals not only cut each other in half, but they're also congruent? So you got way too specific. So there's two types of quadrilaterals in which all four interior angles are right angles. That'd be square and that'd be rectangle. But the only thing we can really conclude here is that this quadrilateral is a rectangle based upon the information given, not a square. If you look at letter B, what did they give us? They gave us that angle X and angle Z are each 100 degrees, making those opposite angles congruent. They also told us that the measure of angle W is 80 degrees and the measure of angle Y is 80 degrees, making those opposite angles congruent. We also can look around and notice that any pair of consecutive angles are definitely supplementary, working around this quadrilateral. So that's also true. So which special quadrilaterals does that hold true for in terms of these angles, where both pairs of opposite angles are congruent and any two consecutive angles are supplementary? Well, if we think about the choices here above, okay, does that hold true for a rhombus? It does hold true for a rhombus, but they didn't tell us that all four segments are congruent to each other. If they told us that all four segments were congruent to each other, then we could conclude that this is a rhombus. But we're not sure about the four segments being congruent to each other, so we cannot conclude this as a rhombus. We can definitely say it's a parallelogram, but not a rhombus. If we take a look at C, is this a trapezoid? Well, in order for this to be a trapezoid, it would have to have one pair of opposite sides parallel. Well, what do you notice? The measure of angle KLM is 90 degrees, and the measure of angle JML is also 90 degrees. So those two angles right there are 90 degrees. What does that also tell us? That also tells us that segment KL is perpendicular to segment LM, and segment JM is perpendicular to segment ML. What does that tell us? That tells us that these two lines are definitely parallel. So if we have shown that one pair of opposite sides in its quadrilateral are parallel. So yes, we can conclude that this is a trapezoid based upon the given information because we have one pair of opposite sides parallel of this quadrilateral, now making it a trapezoid. Great lesson today. I hope you had fun.